Okay, so this is the nth term that we're looking at today. Now, when we say the nth term, I think certainly in this case, I think what you would mean is quadratic sequences. But just to be on the safe side, I will mention a couple of the other terms that can be included. Some of the other sequences that we can mention as well. Let's just briefly touch upon what we mean by the nth term, though. So I will actually do one on a brief linear sequence. So we'll say, let's imagine the sequence starts with 5, and 7, 9, 11, 13. So this is a sequence of numbers, and your job in all situations like this is to identify the pattern, and hopefully you've noticed that it goes up in twos. So what do we mean by the nth term? Well, it means we know that this is the first term. So we say n is 1 there. This is the second term, so n is 2. This is the third term, so that's n is 3, and that's 4, and that's 5. So if we say that this is the fifth term, and this is the fourth term, well, the n is this number here, right? So when we say the nth term, we're just referring to one of these terms, and depending on the term that we're referring to depends on what n is. So if n is 4, then the nth term, we're talking about the fourth term. Okay, so I just wanted to make that clear, as a lot of people can sort of throw the expression around a little bit without delving into really what it is that it means. So with the linear sequence that I've just done there, well, what we do is, so first of all, how do I know it's a linear sequence? Well, I can certainly suspect it's a linear sequence because the difference between the numbers is always the same. So 5, 7, the difference is always 2. So the nth term in this linear sequence is going to be something multiplied by n, and that something is what this difference is, 2n. Now, the first term, if the nth term was simply 2n, then the first term would be 2 times 1, because the first term would be when n is 1. The nth term, first term is when n equals 1. So first term would be 2, but it's not, it's 5. And so what's happened is we've added 3 to it. So just to be clear then, so the second term is going to be 4 plus 3, which is 7, and so on. So this is the equation for that sequence there. Now with a quadratic sequence, well, let's look at what happened for a quadratic sequence. Let's write out the first 3 terms in this sequence. So this time I'm going to use a table. Let's make the table. Don't want it like that, do I? Okay. So I'll make a table. So we've got n, 1, 2, 3. We just want the first 3 terms. So the nth term is going to follow that equation there. So 1 squared, which is 1. Oops. So minus 2 times 1, which is 2. Then we're going to add 8. So that gives us 1. Take away 2, take us down to minus 1. Add 8 equals 7. Next one, we have 2 take away. So 2 take away 2 times 2, which is 4. That's not right, is it? So 2 squared is 4. So take away 2 times 2, which is also 4, plus 8. So that's just equal to 8. And the third term is 3 squared, so that's 9. Take away 2 times 3, which is 6, plus 8. So that's 9 take away 6 is 3, add 8, that's 11. So I'm going to do the fourth one as well. You might want to pause the video and see if you can work out what you think the fourth one will be. Yeah. Okay, so the fourth one is going to be 4 squared, which is 16, minus 2 times 4, which is 8, and then plus 8. So that's 16. Okay. Now the difference here seems to be changing. So 8 to 11 is 3. 11 to 16 is 5. We call this difference, and the same in the linear sequence we just call it the difference. But in the quadratic sequence, we can call this difference here the first difference. The second difference is the difference between the difference. And that, for a quadratic sequence, will be constant. So if it's not constant, it's not a quadratic sequence. Okay? And if this is staying the same, it's a linear sequence. So if you got a different first difference and a different second difference, as in they're not constant, then you're not looking at a linear or quadratic sequence, you're looking at some other type of sequence. So what we'll do is we will try to, so we had a go at some of these. Let's go to 13. Yeah, let's go to 13 then. So again, you might want to pause the video and see if you can do this. And then I'm going to do it. So hopefully you've unpaused it now. You had a go at that and you unpaused it now. And so 9 to 17, well, that would be 8. And let's do it down. There's not much space, is there? Okay. So 8 and then 17 to 29. I'm just going to pause the video and do all of these. So the first difference is 8, 12, 16, and 20. And the difference between all those, you can see, is 4. So the second difference is 4. Now, the formula for a quadratic sequence is something which, what I'll do is I'll do a gap. Something multiplied by n squared plus something multiplied by n plus something. So the nth term, in other words, the first, the second, the third, the fourth term, whatever term, is equal to that formula. Now these somethings are labelled as a n squared. So a, sorry, is the first something. And then, hang on a second. So, yeah, sorry, the first something is called a. The second something is called b. And we've already labelled that one as c. So what we do to find out a is we take the second difference and we half it. So if the second difference is 4, therefore a is 2. So now what we're going to do is going to draw a table. So first column we're just going to label as n. And so we've got 5 terms. We've got 1, 2, 3, 4, 5. The first 5 terms. And then the next column we can label as the nth term. I'm just going to write nth. And that's going to be, well, the first term was 9, then it was 17, 29, 45, 65. The next column I'm going to label as an squared, or in this case 2n squared, because a is 2. So, well, n is 1 and n squared would be 1 as well, so it's going to be 2 times 1, so that's 2. Then it would be 2 times 4, which would be 8. Then it would be 2 times 9, which would be 18. 2 times 16, which would be 32. And 2 times 25, which would be 50. Now, next bit is if we say that the nth, so let's write this formula, nth term is equal to that. Let's use a bit of highlighting here. So that's that bit there. If we were to subtract, let me just highlight this bit as well. I don't know why that keyboard comes up. I've already spoken to him about it. It just doesn't. There's no reason why it should come up. So what I'm going to do is I'm going to subtract this green term here from both sides. So I end up with nth term minus an squared. It's kind of a weird thing because we're going to, I mean, it's not too weird to understand what I did there algebraically. I've just rearranged the equation. But what we can do now is what we should get is bn plus c. In other words, we'll get a new sequence, and that's kind of a weird idea. So what I'm going to do is in this. Okay, let's just. This line tool is a bit weird sometimes when you're not used to it. So let's do. So this we're going to do. And so you could write in this third column, you could write nth term minus 2n squared, or you could just write bn plus c. I'm going to write bn plus c because it takes up less space. But I can see it's going to be worked out by doing the nth term minus an squared, or in this case 2n squared. So 9 minus 2 is 7. 17 minus 8 is 9. 29 minus 18 is... Okay, I'm going to pause the video and do the rest of them. And I want you to see if you can do the rest of them yourself. Okay, so hopefully you should have got these values. And have we got this right? I mean, it's always a good idea to be able to look at your notes and look at your work, your answer so far, and ask yourself, does this look correct? Well, this goes up in a constant first difference. So this is a linear sequence, and it should be a linear sequence because n is to the power of 1 in this case. So we have a new sequence just called bn plus c, and I've got that by taking away the an squared term each time. So we know, as at the beginning of the video, I showed you how to do the linear sequence. So we treat this the way that we would treat any other linear sequence. If the difference is 2, then b is 2. Okay, so b must equal 2, and then we just think the first term would be 2 if it wasn't for this c value. So c must be 5 because, and this is the upside down 3 crosses, bn plus c equals 7 when n equals 1. Whoops, when n, 2 n's there. When n equals 1. So in other words, we've got b, which is 2, times 1 plus 5 is equal to 7. So now we can put them all back together, and we can say let's write this in a different colour. So the nth term, I'll write it on the answer then, is going to be 2n squared plus 2n plus 5. That should have been what the final answer is. So let's have a go at another one. we'll have a go at this one, and I want you to I'm going to pause the video. I want you to pause the video and have a go at it, and then I'm going to start by filling out the table. Okay, so far I've got that much, and what we need to do is, I haven't actually worked out the second difference then, so if you haven't done that, have a go at that. Okay, so the second difference, you can see this is the first difference, and these go up in fours. So the second difference is 4. So therefore A is equal to 2. So now we're going to fill out this formula, this column here. And it's the same as the previous one, isn't it? Because it's A 2 again, so I've just copied that down. And now we're going to do Bn plus C, which remember is the same as the nth term minus an squared. Okay, so we're going to minus the pink column, going to minus the green column from the pink column. Okay. So we see something very interesting here. It doesn't seem to be going up, it stays the same. So what does that linear sequence mean? Well, let's just treat it the way we would normally treat it. The difference is 0, so therefore B is 0. Well, if B is 0, then Bn, so therefore Bn plus C is just equal to C, because 0 times n is 0. So now we just need to think of, well, what would that mean for the C value? Well, if n is 0, so when n is 1, then Bn plus C is equal to minus 5. So basically, what it means is C is just going to be it's minus 5, because we can see that in all cases Bn plus C is minus 5, and so it doesn't matter what B is, it doesn't matter what n is, in fact, because it's going to be multiplied by 0. So for the first term it's minus 5, for the second term minus 5, and so on. So what this ends up being is that the nth term in this case is just going to be 2n squared minus 5. Okay, so you can have a go at the other ones as well if you like. You got the answers up here as well. And then the later questions are kind of application questions. You've got to identify what the pattern is based on geometric patterns. And then there's probably some wordy. We could probably have a go at these on Friday. But okay, that's all we've got time for today though.